we're going to look at rational exponents. A rational number is a fraction. So rational exponent means the exponent is a fraction. Recall that we have talked about a positive exponent. For example, 3 squared means the exponent, when the exponent is positive, it means the number of copies. So it means we multiply 2 copies of 3. But when the exponent is negative, for example, 3 to negative 2, it means the reciprocal, the negative sign in the exponent. Wait, hold on. So let me put negative here. When the exponent is a negative integer, I should emphasize integer, a positive integer and a negative integer. And this means the reciprocal of 3 squared. So the negative sign in the exponent, when we change the exponent from a positive integer to negative integer, it just flips that. So you get 1 over 3 squared, which is 1 over 9. So remember, a negative exponent. So positive exponent means the number of copies. The negative integer as exponent, it means the reciprocal of that positive exponent. So I'm just going to put the reciprocal here. Well, so today's topic is going to be a fraction. So what if the exponent is not positive integer? It's not an integer. It's a fraction. So we have, let's say 3 to 4 halves. Let's change it to 5 halves. So 4 halves can be simplified to 2. So I'm going to keep it as a proper improper fraction, 5 halves, a simplest form. And so what does this mean? Of course, it cannot mean as positive integer number of copies, because it doesn't make sense to say 5.5 copy of 3, and because we cannot take a half copy of number, and it's not negative, so it doesn't mean reciprocal either. So the fraction as an exponent, it actually means let me put it, if it's a fraction, it means a radical number. So this is going to change the base, the number to a radical number. And so first we put a radical sign, and the top, the denominator of the numerator of the fraction will stay as the exponent of 3. So we're going to have 3 to the 5th. But this 2 means 1/2. This 1/2 will become the little index. So this actually means 3 to the raised to 5 halves means the square root of 3 to the 5th. So similarly, if I have, let's say 4 raised to 7 thirds, that means first I put the radical sign, and the top, the numerator, will stay as the exponent of 4. So we're going to get 4 to the 7th. But the bottom, this denominator 3 will become the little index, because this 3 means 1/3. So 1/3 means the index. All right. Well, we can simplify this further, because we know that this is not the simplest form. So we're not going to do it here. We're going to here I'm just explaining, use this as an explanation of what a fractional exponent means. Next, we're going to look at example, and I will show you how to simplify it. Okay, so how about let's look at if I change this 3 to 9, to do 9 to the 5 halves. So by the definition, it means 9 to the 5th, and then take the square root. So this 2, the square root 2, can be omitted. And from what we learned before, if you have 2 copies of anything, you should take out the square root sign. So this means we have 5 copies, 9, 9, 9, 9. That means we can at least take these 2 copies of pair out, these 2 out, And then we're going to get 9 times 9. So when 2 copies come out, you get a single copy. These 2 come out, we get a single copy, 9. And then there is another, so let me mark this way. And there's another 9, but this 9, so let me do one more step. And the last square root of 9 is also, because 9 is a perfect square, we can actually simplify this part to get a 3. So we have 9 times 9 times 3, which give us 81 times 3, that's 243. Okay, so that's one way to simplify as what we did before. First, we change the rational exponent to the radical number and then simplify them. And similarly, for these 2 examples that I had, you can do the same thing to try to simplify. Maybe I can work out this second one, the cube root, because I already did a square root here. So the cube root, what we do is, because 7 copies means we have at least 7 copies of 4 contain at least 3 pairs of 4. I'm sorry, 2 triples, because we need to take out 3 copies. Let me just write down all the copies. And remember, every 3 copies can come out. And so we're going to have 4 times 4. These 2 copies come out, you get a 1 copy. These 2 copies come out, we get a single 4. But there's another 4 left. Notice it's cube root. We need 3 copies of a number, but 4 is only 2 copies of 2. We cannot simplify this further. But we can multiply 4 and 4 to get 16 cube root of 4. So that's how we simplify the rational exponent. But there is a different way to do this kind of problem for special cases. For example, so this this example that we did, I'm gonna do it in a different way. But notice the way I am going to do next is only works for special problems like this. I'll explain why this one is special. Okay, so here we are going to, instead of change it to a radical number, that's the definition. By the definition, we can change a rational exponent to a radical number. But I can also use the exponential rules that we learned before to do this kind of question. So let's review the exponential rules we learned before. So we have learned that the rules we're going to be using is this one here. When you raise nth power to an nth power, we are going to multiply the powers. So that's the formula we learned. But this time we are going to the exponent we talked about before, they could be positive or negative. And these formulas, those 5 formulas we learned, exponential rules, we also work on rational exponent, which means fractions. So if you have a fractional exponent, you can still use the formula. So even this n here is a fraction. So here's the idea. We know that if it's a fraction, then you have, if you do it by definition, you're going to have to change it to radical number. But if it's a integer, it would be very easy. Just take a number of copies as we explained here. So if it's 2, it means multiply 2 copies. Compare this problem right here, and when you have a positive integer as exponent, and compared to this one right here, when you have a fraction as exponent, as you can see, it takes a long time to simplify radical number. So the idea is, can we do some operations to get rid of the fraction there? Notice that this doesn't always work. This only works on special cases, because 9 is can be written as 3 squared. It's a perfect square. So I'm going to rewrite this number 9 here as 3 squared. And normally when we see 3 squared, we have to square it to get it, multiply 2 copies of 3 to get 9. But here we're going to reverse the process. When we see 9, I want to change it back to 3 squared. And you're going to see in a second why we're doing this. So 9, I rewrite it, but the fractional exponent will still be there. And notice that we have this formula. When you raise the exponent to another exponent, even if it's a fraction, the formula still works. So 2 powers right next to each other, we multiply them. So we get 2 times 5 halves. And we know 2 times 5 halves. You can cancel those 2's to get a 5 by multiplying fractions. So we're going to get 3 raised to 5th exponent. And now it's much easier to do because 3 to the 5th, you multiply 3 5 times. You multiply 5 copies of 3. You are going to get exactly the same thing as 243. So the same answer as what we got. So this is a different way to do it and to avoid, so we can avoid radical numbers. But it only works for the special cases like this, because the 9 can be written as perfect square, 3 squared, and this 2, the square will cancel that half here, because one half means square root, so square cancels square root. That's why we end up with the integer as an exponent. But it doesn't work for all of them. For example, in this case, the base 3, I cannot really like it as perfect square. So the only way you can do is this way by definition. Or in this case, 4, it's 2 squared, but the bottom is cube root. If you change 4 to 2 squared times 7 halves, 2 times 7 halves, it's still not gonna get an integer, you still get a fraction, 14 over 3. So it's not gonna make it any easier. And so the only time it works is when you rewrite the base as an exponent, and this exponent can cancel that denominator in the fractional exponent. You will end up with the integer as exponent. The next, we're going to look at some more examples here. So what if we do 125 raised to 2/3, a fraction? So first, let's see if we can use the exponential rule to get rid of the fraction, the fractional exponent. The 125, if you're familiar with those cube numbers, we know 125 is 5 cubed, and then raised to that 2/3. So first thing I did is to rewrite this base 125 is replace it with 5 cubed. And then I'm going to use the exponential rule. Notice that these two powers right next to each other. We multiply the powers, and 3 times 2/3, 3 cancels 3. We get 5 squared, which is 25. And this way is much easier than use the definition to change to radical numbers. And next we do negative 16 raised to 3 halves. So notice that that negative sign it's not in the parentheses, it's not raised, so negative sign we will leave it. We're just going to rewrite 16 as 4 squared, and then raised to 3 halves. And use the multiplication, the rule of exponentials numbers, where we are going to multiply these two exponents, 2 times 3 halves. And that gives us negative 4. 2 cancels 2 to the third. And negative 4 to the third is 4 times 4 times 4. That gives us negative 64. Now what if it has a fraction in here? And when notice that negative exponent means reciprocal, so we can go ahead and flip it to get 64 over raised to 4 to 4/3. Because negative exponent means you flip the reciprocal. And then, flip the base. And then we can rewrite 64 as 4 to the third, and then raised to 4/3. And apply the rules, exponential rules. Power of power, we multiply the powers. And now we can cancel these 3's, and we end up with 4. The exponent becomes integer 4. And integer means a number of copies, so we do 4 times 4 times 4. That gives us 256. So this is a different way to simplify a number raised to a fractional exponent.